thank you very much for the invitation. I'm not an engineering, I'm a physician, and I will try to convince you that we need your help in order to improve the quality of life of the elderly population at this day and in the next few decades. So let's begin. So as we know, the world is aging and more elderly people will see in the next few years. And for example, if we take a look on the situation in the United States, for example, the definition of elderly is above 65, but it's very fluid. But for example, in 2000, it was about 35 million, and in 2050, it will be more than 80 million. So 2050 is not in the next few years, but when we discussed about this issue, it's how we will be elderly in 2050, and we'll try to improve our quality of life. But more important is the number of patients above 80 or 85 years old. Patients at age 80, 65 years old are quite young today. But if we saw at this population, the oldest old, it will rise from 5 million to 20 million. And it's all over the world, even in Israel and other countries. So what's have changed during the COVID-19? People and mainly elderly population at home, and the loneliness, while the nursing home was very, very unsafe and catastrophe. We have heard about it in the news, and we saw the death from there, the high number. And the results will be stringent, empower the remote care and the home care compared to the care of the oldest old in the hospitals and the nursing home. So it's not only due to the COVID-19, but due to the COVID-19, the government, the policymaker understand that this solution has many, many problems. So in the next few slides, I'll try to summarize a one semester course of what is aging in 10 minutes in order to understand the barriers in order to get the best solution for this population. So what is aging? If we take a look on these persons, they're all 65 years and old, but you can see the right one is very, very frail, while the small one, the left one seems very young, but meanwhile he is getting older. So how do we define aging? So I try to focus on these three pillars, frailty, networks of elderly, and giants of geriatrics. So what is a frailty? When you take a look on normal people, young people, and they have entropic forces and homeostatic mechanism. So for example, if we have a viral infection like a flu, cough, short of breath, so young patients in middle age, with the presentation will be a fever, short of breath, cough, and no other problems. And usually he will get antibiotics a few days at home, and then he will be healthy. After a few days, he will get back to the work. On the other hand, if we take a look on the age-related frailty, the homeostatic mechanism is very, very narrow. So in case of even flu like influenza, usually the problem is not that you don't have the right antibiotics or other treatment to give him. Because when he comes to the hospital, then he have a problem with his lung, and then with his heart, and then he has a fluid overload, and the blood pressure goes down, and everything gets crushed. So frailty is the best phenotype of what we defined as aging, that minimal reserve of all the organs, of all the systems in the body. So it's the frailty. And how can we define frailty? When you see a person, as we see the picture before, you see a frail patient, you can see it's a frail. But in the literature, when we do studies, we want to define it. So it's, you see on the on the on the definition, it should be include 3 or 5 criteria, and it's very low tech. On the contrary to other fields in medicine. For example, low energy level, decreased physical activity, slow movement less than a meter for a few meters, decreased hand grip, and loss of 10 or more percent of body weight. So if you can see, at least 4 of the 5 criteria are not measured usually uh, by the physicians, but it's very, very important phenotype of the elderly. So what's the consequence of frailty? If you can see at this slide, we can divide the energy in the body to 4 parts. The first one is the minimal for minimal energy requirement. For example, the brain, the kidneys, the heart, when it's in rest. The other part is the postprandial energy, because we eat the food, and the food is converted to ATP. As you know, every transformation needs energy. But we are focused on these 2 parts. The first one is the physical cognitive activities. So as much as the patients work more and more, and he doesn't rest, this part will increase. While this part is the most relevant part for case of disease. So there's the extra energy for unstable condition. So our aim is to increase these parts. And when the patients or the persons is inactive, he will lose this part. While he is increasing his activity, so this part will increase. So our aim is to maintain functionality, walking activity, in order not to lose this part. So it's a frailty. The second point is networks at elderly. If you can take a look, it's a cancer cell, and we see many proteins within the cells. So I'm also an oncologist, and if you, for example, have a specific protein which can inhibit specific network, for example, this protein, the cancer will increase growing after a few days or after a few months, because you have very other alternatives. And if we can take a look for illustration at the networks of the Tokyo subway, and we hope we will be able to come back to there in the next few days or months. If we want to get from the airport to the city center, and there is a accident or other problems here, there is no problem. We can change our way in other pathway. So what is the relevant for elderly? Is, falling is a major problem in the elderly. So in this very, very simple trial, they took elderly patients, and they want to see who will fall in the next year. And they asked them to count 50, 49, 48. And this population who did it, when they was not able to maintain the same speed while they counting 50, 49, and etc., has odds ratio risk of 33, more than patients who are able to do these 2 tasks together. So what does it mean? It means that the connection within the brain, and it's not also brain, as we'll see in the next few slides, who is able to do something simultaneous and not all the energy to specific place, is a very, very, the reserve is he has a lot of reserve, and the chance to fall is very decreased. And the last point is the giants of geriatrics. Usually we want to treat the disease, but in geriatrics, as we mentioned, the most important thing is to maintain ability, activity, and function. So usually in geriatrics, if there's a disease, then there's the giants, and the giants might be immobility, instability, incontinence, and the patient stays in bed, intellectual impairment, and iatrogenesis. I'll speak about fall, then instability and immobility, and then the decrease in function, loss of muscle mass, and the consequence of frailty. So if I try to convince you that the most important thing is the biological reserve and age, does the chronological age matter? So if we take a look on this very old article from the New England, they took a look on the marathon records for men. And if you can see, the record is about 2 hours, but marathon men above the age of 30 getting slower. So it seems that aging is beginning before the age of 30. And if we can look at this slide, above the age of 80, in spite of improving medical care during the last decades, it seems that the number of a person above the age of 100 is very, very limited. So above the age of 80, 85, there's the frailty, people getting older, and I can try to explain why it takes a lot of time, but there's a internal clock within the body, and at the age of 80, 85, people getting elderly and with high rates of frailty. So I'll try to summarize this part. Geriatric is a multifactorial. There's the biological age is very important, but chronological age above the age of 80 is very important. And the COVID effect will transform and care from hospital and nursing home to home. So I'll try in the next few minutes to illustrate the problem, the main problem, and the solution that has been established and what we can do. So fall, in order to prevent fall, we have to understand why people fall. And the normal walking is by input, like a machine, by vision and from the ear equilibrium, and then process like a computer in the brain. And every problem in the brain might impair this process, like mental health problem, which increases the risk for falls because the processing in the brain is impaired. And the output is the muscle. And as we saw, a weakness and frailty increases the risk for fall. And above of it, environmental factor might increases the risk. And the consequence of falls is physical, immobility, mental problem, and social isolation. And how we can prevent it? It's very good solution, but it's not so suited for patients or persons who wants to walk, and we want to maintain a walking and activity. So first of all, many like airbags in the car, but it's very, very inconvenient and it's very not so prevalent. The best thing is they try to perform exercise in order to illustrate falling, and then to try to learn the person how to fall in safety way. Other thing is alarm when in case of fall, but just after falling in order to prevent staying on the floor for many hours. And then a new show that it's a startup from Israel who tried to learn about the specific patients, how does he walk, and how we can improve online his stability in order to prevent falls. It was about falling. Another problem is the iatriogenesis. It means that our medical care can cause damage to the patients, mainly medication like sleeping pill. It causes instability and decreases function due to falling and other problems. So polypharmacy, it means patients who takes a lot of medication. The definition is more than four tablets, 4 medication per day. So it seems many elderly patients take a lot of medication and the number is very, very high. For example, here for Canada, about 2 or 3 elderly patients take more than 5 different medication. About 1/3, about age 75, takes more than 10 medication. And the risk for drug adversity high. On the other hand, even patients who need medication for chronic disease, the compliance is not very high. For example, about 1/3 of hospital and nursing home admission is due to problem in the adherence on changing the medication in the long term. So it's the only to prevent unnecessary medication on one hand, and on the other hand, in order to increase the compliance for patients, mainly elderly patients. And these patients may be at home alone with a cognitive impairment and other problem. So there are many solutions for this. For example, when the patients take the medication, does the caregiver and the family knows about it, or like a tablet, which can you remember the patients to take the medication. Another solution is when you open the bottle, then there is a sensor which the iPhone knows about that you take the medication. And a new solution, but it's very, very highly cost. It's an ingestible pill sensor. When the patients ingest the pills, then the sensor will transform to the iPhone the information. On the other hand, in Israel, the interaction to check interaction between drug 1 and drug B, since interaction and increases when the patients take more and more medication. It's regarding the medication. The third issue that I want to discuss is remote medical care. As you understand, we can give the person at home wearable sensor, and then the medical staff can identify problem. And there are many sensors. I'm not focused on this, but as you can see, for example, on the body, there's a sensor for cardiovascular system, knee joints, activity monitoring, saturation, and brain. But the most noble thing is robots. We can help and aid people who lives alone in order to help them to take medication and not to be alone. But our question is, should we want to take care of our parents or ourselves in the future, to take care of patients who lives, or to take care of robots? So we have to be, we can give him a lot, give the persons a lot of sensor, but we want to take care for persons and not for robots. And the last issue is barriers to big data. We know that big data for medicine can identify population at risk, for example, from blood test, medical examination, lifestyle history, and then to get the best solution and identify disease or to focus intervention to specific population. But we know from computer science that garbage in is garbage out. And as I try to convince you in the beginning that one of the most important things of the elderly person is the activity, the frailty. And this data is not available in the medical health record usually. So if we want to predict adverse health outcome, we have to get the right sensors and the right data. And as we saw, frailty is composed of a physical dimension. Usually patients don't have a wearable device in order to see how much they walk, a psychological dimension and social dimension, which can affect the frailty of the patients. And if we want to give the persons a lot of sensor, we want to take care of patients, persons, and not robots. So what is the take-home message? The problem and the care and the needs, the unmet needs of the elderly population will increase in the next few decades. It's very complex mechanism, and when you see patients who fall or recurrent falls, it's not a one pill can solve or a one device can help. It's multifactorial. But on the other end, we want to take care for persons and not for robots. So in my point of view, the aim is to prevent the deterioration, to maintain ability, functional, and then we will have a better health, mainly for the elderly. So if you had any questions, I'll be happy to answer. And I hope that next year and next years, you will go to Ariel and then you are invited to Jerusalem.